Weight is a function of gravity. If I weigh 132 pounds on Earth, I'd only weigh 44 pounds on Mars and 22 pounds on the Moon. My mass never changes, only my perceived weight changes. Huh, you didn't get that? Do you speak alien? This guy's a little confused about the difference between weight and mass. Sure, he wants me to explain. I don't mind. Mass is a measurement of how much matter is in an object. Weight is a measurement of how hard gravity is pulling on that object. Your mass is the same wherever you are, on Earth, on the Moon, floating in space, somewhere near Pluto.
Remember me?
I remember you. Because the amount of stuff we're made of doesn't change.
Later.
But your weight depends on how much gravity is acting on you at the moment. You'd weigh less on the Moon than on Earth, and in interstellar space, you'd weigh almost nothing at all. If you stay on Earth, gravity is always the same. So it would seem like it really doesn't matter whether you talk about weight or mass. But scientists still like to be careful about distinguishing between the two. If you talk about the mass of an object, it will always be the same no matter if it's on Earth or in space. But if you talk about an object's weight, that can change depending on gravity. Let me give you an example of weight. If I stand on this scale, I weigh 132 pounds. Now, if I hold a 10-pound bag of potatoes, the scale says I am now 142 pounds. This bag of potatoes isn't a part of me, so I am not really heavier, but gravity has perceived a change in my mass. Or maybe just that I've possibly eaten 10 pounds of French fries. You see, gravity works on the whole object together, not just on one part. The extra gravity force registers as increased weight on the scale. This is getting heavy. I'm going to drop a little mass. Whoops, mashed potatoes. Little science joke. Let's review again. The bigger the object's mass, the more gravity it will have, and the smaller the mass of the object, the less gravity. And the force of gravity depends on the distance between the centers of the two objects. The closer they are, the stronger the gravity will be.